we discussed discussion about substation and substation layout. Now we are moving to the real distribution part. Distribution is actually almost similar to transmission. Other like the components, if you discuss, it's mostly same. There will be, instead of towers, now it will be poles. Then transmission lines which we used will be that aluminum conductors. But when it comes to distribution, we don't consider this ACSR because there are a lot of joints and such things. So it will be mostly aluminum conductors if it is overhead. And like we study for transmission, there will be overhead system and underground system. Like we have in our city, it is underground system. Then we will use XLPE cables, not aluminum overhead lines, not poles, but there will be underground trenches and cables will be connected. But basically the structure of the distribution system will be like we study in the first lecture of distribution. There are 6 levels: sub-transmission, transmissions, substation, then primary feeder, distribution transformer, secondaries, and finally a connection coming to your home. This is the basic structure. Now, that structure is a basic 6 levels. And how these distribution lines are connected, based on that, we have different types of distribution systems. Today, we are going to study about these different types of distribution systems. Basically, there are 2 types of systems. One is radial system, other is loop system. The lab which you did is based on radial system. Okay, we will come to that. This picture is an example of a radial system. You have a bulk power source. This can be a power substation or a power plant. From there, the primary will start. There is a substation here that will step down from now here there is a substation which will step down from transmission level to sub-transmission level, and this sub-transmission line is going like this, and it will end up in some distribution substation. This is one distribution substation, this is another distribution substation. From that distribution substation, many primaries will start. Each primary will end in a distribution transformer. From that distribution transformer, here actually only one secondary is came, but another example, if you take here, you, from here, all these examples are only one secondary came, but from here more number of secondaries, maybe like these branches, here also many branches of secondary will be going. From each secondary, many connections to different houses will be going. But if you look at here, you can see it is like a branches of a tree. A main root, then it is split into 2, then this is split into different roots, then it is split like this to reach, if this is the load, to this load, to reach from here to here, you have only one route. Like exactly you have to come through this. Each and every route is connected through a unique path. This type of distribution system is called radial system. The distribution lines extend from the substation to the last load with service drops or service connection of the customers along the way. Just one route is there. This is like spokes of a wheel or like a branches of a tree. That's why the name radial system. The advantage of this system is it is simpler because minimum number of lines will come, minimum circuit breaker will come, minimum protection will come, and therefore it is most simple technique as well as it is more economical technique. It is easy to install also. But there is a disadvantage. If something happens here, this whole area will be disturbed. You don't have an alternate way to give supply to these customers. So usually a problem will leave a number of customers out of service until the problem is solved. So this is the problem of uh, radial system. It is simple, economical, but there is a problem. If something happens, a large number of customers will be out of service. To solve this, there is a modified radial system where only sub-transmission will be connected with two parallel radial systems. This main sub-transmission line, this main line, there will be two lines. So if something happened to one line, the second line will supply only sub-transmission level, not into all levels. Sub-transmission level is covering a large area of the city. Therefore, this is more critical. So there only you will put two parallel lines so that it will give more reliability. It's a modified form of radial system. Loop system is actually the most improved type or more reliable type of system. It is very reliable. Loop, why it is called loop? For example, to reach this customer, you can reach normally through this route, it will be supplied, either this or this exactly. Okay, through this, it will be supplied. Here in between, here, there will be a circuit breaker. This will be open so that all these customers will be supplied by this route and these customers will be supplied by this route. Also, this line will be normally off. All this will be supplied by this line and all this will be supplied by, oops, all this will be supplied by this route. This is an extra line to make that loop. There is a circle. So that if something happened to this line will be turned on and this line can supply through this to this loop. Or if the problem is something, if something happened here, there is a circuit breaker. This circuit breaker will be closed so that all these customers can be supplied from this side. Like this, for every problem, like this, there will be two circuit breakers on both sides of every connection going out. So that at any point, you can supply from two, at least minimum two directions. Each and every point in the power system is supplied from two different directions so that wherever a problem comes, it can be supplied from other side and it is the most reliable type. These are the two types of system, a radial system and a loop system. But the actual system is actually a combination of this loop and radial. This is one of the most common way. What we will do is, you can see this a combination. Here you can see a loop system and here you can see a radial system. What we will do is, for the critical customers like industries, hospitals, or big shopping malls or colleges, this type of big loads, high level loads are supplied at using the loop system, and residential customers like this non-critical loads will be supplied with the help of a radial system, so that you can improve the overall reliability. Also, you can reduce the cost. Can be economic and reliable. We go for a compromise between this radial and loop system by compromising the reliability and cost. This is the system which we use. But these are the basic structures. But when it comes to the cities, big cities, again the picture changes. If you think about the big cities, in a small area, it will be multi-storied building. A lot of lots will be coming, lot of offices, lot of apartments in a small area. So such cities are not supplied like the system which you see in our city. Like here, it is underground. Everywhere it is underground. Even big cities also it is underground. But it is not like, okay, one feeder, then there is a transformer from the secondary start. It's not like that. All these components are there, but all these components are connected like a network. So different feeders. This is here in this example, only two is shown. Maybe 10 feeders primary feeders will be coming from different directions of the city. That will be connected like a network to the distribution transformers. From there, the secondaries will start. These secondaries will be again connected through the Between each building, there will be roads. Under the roads, these secondaries will be passing. And from these secondaries, it will be, all these are connected. Like network means always, this is not a junction. This junction is through circuit breakers. From which direction you have to take power, like this can take power. If you close this switch to this side, this will be supplied from this. If you close this switch to this side, it will be taking power from this. If you open this and this close, and this, if you close, this load can take power from, and if you close to this side, from here. If you close to this side, it can take from power from here. Like this, it can take from, if there are 10 feeders, every load in the city can be taken from any of these 10 primary feeders. Like this, it will be a network of these primary feeders and secondaries. This type of a system is called network. Networks are designed to provide very reliable service to areas with dense loads like downtown or suburban business districts, multi-story buildings, etc. And like we study about this primary feeder, it will be normally 13.8 kilovolt here, or even 34.5 in some places. And the secondary will be 208 120 volt, and it will be like you see in this picture. Now, there are some special cases. One is spot network. We have a network of 208 and 120 network. This is the normal building. But there may be some special cases in that building itself which need some higher voltage. Some special workshop or some industries running in the same building, they may need a higher voltage. For that, we will make a sub network inside that network with a different voltage. That different voltage network which is made inside this main network is called spot network. So since it is high power, there will be high capacity lines, high special protective devices, etc. Everything will be connected for this one. Then another thing, important thing, is individual feeder. Individual feeder, as we see in the results of lab, which maybe you are going to do this week, you can see a big difference in, or last week which you did, the lab, the losses, the voltage drop of individual feeders are less. This is one advantage. But there is another main requirement for individual feeders. Individual feeders are normally used for critical loads. Individual feeder means you are giving a feeder, primary feeder, directly to a load. For example, a hospital. If something happened to somewhere near the hospital, the power supply to the hospital should not be disturbed. For that, we will give a dedicated primary feeder to the hospital. Not only one, there will be alternate sources, but that connection to the hospital will be only for that hospital. So that any fault or anything happens nearby or surrounding area, not going to disturb the supply to the hospital. Like this type of critical load, the individual supply given to some critical loads are called individual feeders. Normally, it will be at, for our case, it is 13.8 kilovolt. This is the standard voltage which that is that primary feeder voltage we are giving this voltage, not sub-transmission level. This is the system. Now, another classification. Types of distribution system can be based on voltage. We have different voltage systems and different number of lines. One of the common type of simple type of distribution, low voltage distribution system is single phase 2-wire system. There will be a phase line and a neutral line. But the most common type is a 3-wire system. Actually, a 3-phase 4-wire system we are using. This is the most common type, 3-phase 4-wire system. Here, there will be 3 phases and a neutral. phase to phase voltage will be, sorry, phase voltage will be 120 volt and the line voltage will be 208 volt. A single phase 3-wire system. This is the special one which we use here. We have 120, 1 ton 220 system. That is this 1 ton or 120 240 system. There will be two phases and a neutral line, but these two phases are again made from the same phase. It is again single phase, not three phase. Then there is a three phase 3-wire system. This is three phase system without a neutral. Then three phase 4-wire system is there for higher voltages. Three phase 3-wire system for higher voltage like 600 volt. And there is three phase 4-wire system for even higher voltages like 600 voltage. This is a system which is used for this single phase 3-wire system. It is with the help of a special distribution transformer with a special secondary winding. Actually, it is made from a single phase, and this artificial neutral is made by splitting this single phase into two pieces. Again, it is single phase. If you connect between this artificial neutral and one of the phase lines, you will get 120 volt. And if you connect between these two, now the voltage will be 240. This is how we get 1 ton and 220 system. This is the one which we have in our city. Now the government is changing all into this 208 120 volt system. This system going to be changed. This is, as I told you, this is the common technique. There will be three phase lines and a neutral line. If you take any phase and a neutral, that is phase voltage will be 120 volt and line to line voltage will be 208 volt. It is three phase, so you can use for lamp loads like in our homes. Single phase loads also can be connected. Also three phase motors etc. can be connected. Then same system but with higher voltage we have. This is about the types of distribution system based on the system as well as based on the voltage or the number of lines used, the systems of